Hello, my name is Emma Money and I'm CEO and co-founder of Cyanoskin. Now we are a new carbon capture technology that works through a living algae-based coating solution. Everybody knows that construction is a widely polluted industry and they're facing pressure from the government, from their clients and from the public to reduce their emissions. This is Joe. Joe is a project manager for a large construction company. And Joe has the currently impossible task of getting his emissions for his company to net zero. Now, he has a budget and he has a clear plan, but unfortunately, Joe can't get there. And so he's turning to things like carbon credits, which are widely untrusted and are still not getting him there to the bottom line or getting him there cheap enough and fast enough. But I want to put that to the side for a second, and I want everybody in this room to close their eyes. And I want you to imagine yourself in the middle of the rainforest. And then imagine you could take that and put that on the side of your building without it taking up any space. You can open your eyes again. That's basically what we do. So we produce a living photosynthetic coating for the outside of buildings that absorbs large amounts of carbon dioxide. So we come to a site, we apply our coating, and then it utilizes the CO2 and the sunlight to grow and forms this moss-like finish. So these are our live samples. This starts from left to right over time. So this is a matter of a few weeks, and then the one at the end is a couple of months. So it's not finished growing yet. It will continue growing, and you'll get a more luscious effect. But this happens through algae and through a process of photosynthesis. And so algae is a great resource. It is one of the oldest organisms on this planet. So it's been around for a very long time. And so the reason that we use it is algae has this incredible capability to grow extremely fast. It takes just a couple of hours for it to double itself. And this means it's extremely cheap. But more than that, it's extremely efficient at absorbing carbon dioxide. So 30 grams, which is about how much I have there, can absorb the same amount of carbon dioxide as a fully grown tree. So this tree here, and this vial here, over the process of about a year, which is a staggering statistic. So we calculated that if we were to paint all buildings globally, we could reduce the emissions by up to 18%. That's over twice the total emissions from cars globally. How do we make money? So we sell the coating and we sell the carbon. It's really that simple. And why would you trust us? So my background is in interdisciplinary design, working on biomaterials and working with algal researchers, professors, and biologists. My co-founder's background is in business, and we have a great set of us biologists and engineers, as well as more than eight advisors that are directors or ex-directors of large organizations that you can see there. So Shell, just to name an example. We also have advisors in deep tech and algae research. We're mainly funded by Innovate UK and also from Imperial, and we've received a lot of awards over the last year, which you can see on the screen now. We've spoken to over 200 customers. We've got 5 signed letters of intent from some of the major players within the UK and globally, and we have 10 customers in the pipeline. And the main thing they're telling us is, can you come tomorrow? We need this now. So we've done our very first pilot. We've got our first samples outside on the scale space building at Imperial. And over the next 12 to 18 months, we're hoping to do 4 more pilots that are going to get us to commercialization and looking at regulations as well. And so we got in June a patent. We submitted a patent for our technology. So now we've got the traction, we've got the plan to get there, we just need the cash. So we're looking for £300,000. So if you are an investor or you know an investor that would be interested and is aligned with our values, we would love to speak to you. Thank you very much, and let your walls do the work and join us to rebuild the world's lungs.
Well done, brilliant pitch. Okay, on to questions. Again, menti.com is open and please do submit yours now. Let's kick off with one about your client pipeline. Tell us a bit more about that and how you acquired them.
Yeah, so the amazing thing about the clients that we have is actually we don't really do any client outreach at the moment. We're focusing mainly on the product and the R&D side of it. So the clients that we have reached out directly to us, and we've got some of the biggest names in the industry, and we are so happy with that. Yeah.
Brilliant. Okay, first question in from the audience. Can it not become dark brown or black over time? How long can it last?
Yeah, so it changes color over time. It starts off just like a standard paint, and then as it starts to transition, it increases in pigment. It increases in whatever the pigment is that it naturally is based. So it depends on the species that you work with. And so the one that we're working with predominantly is green. It depends on how it's growing as to how far it gets. There are certain species that are, there's a really, really dark purple species that basically looks black. And they are single-celled organisms. So when one dies, the other starts to kind of grow and replenish itself. So it doesn't die as kind of one organism. It just keeps rejuvenating itself.
Okay. Is maintenance required? What's the degradation over time? In a similar question.
Yeah, so we have focused really clearly on our R&D at trying to make it no maintenance. A lot of corporate partners, they don't want to have to deal with anything. And so we've kind of had that as a key focus. So at the moment, we're looking at the paint just kind of being completely self-sufficient. And we're trying to, looking at working with different species that do something called a symbiosis. So they help in situations where certain organisms may be struggling with one thing, they'll help provide that and support each other in this.
Okay, moving on to our next question. Where is the best point along the construction value chain via Cyanoskin to enter?
Yeah, so at the moment, we are looking at hoardings. So for anybody that doesn't know what hoarding is, they go around the outside of buildings. They're the wooden kind of structures. And these are amazing for us because they're just kind of, you can remove the structures very, very easily. So there's no risk. There's a lot lower regulations in terms of them. It's very easy in terms of painting. They're all about 2 meters high. There's no kind of, you don't need any structures to actually paint them. So we're working with those, but also the customers that are having the construction that have the hoardings, then obviously are in the process of building a bigger building. So it works really nicely in that once they've had their hoarding painted, they're very much like, okay, now we'll move on to a bigger project. You can paint the actual building. So it works really well for us and it works really well for them.
Fantastic. Okay, next question in asks, how are you handling the moisture necessary for the algae to grow without affecting the building's moisture insulation?
Yeah, so the way that we're looking at this at the moment is there's lots of species that are adapted to different environments. And so we're working with species that naturally live on those dry environments and don't like as much water. So species that exist already on rocks, caves, and things like that. So it doesn't have like a high moisture concentration, but it is something that we record in all of our experiments. As we understand, that's quite key.
Indeed. Okay, what types of walls can it be applied to? Will it work on any material?
Yeah, we have done testings on all sorts of materials, so a lot of the conventional ones. We like substrates that are less porous, but so you might need a pre-application before you do the more porous ones like wood, but things like concrete, bricks and things like that. We've also done quite a lot of non-conventional material testing, so even looking at plastic, glass, things like that. They've all been successful, so yeah.
Fantastic. Okay. How is the algae sequestered?
So the algae sequesters the carbon through a process of photosynthesis. So it's a natural process. It's been existing. It's what trees do. It's what every plant does. And it works in the same way. So it uses the carbon dioxide and the sunlight and turns this into growth.
Fantastic. That brings us to time. Well done. Thank
Perfect.
you.
Thank you so much.